Recording. So, I hope we are following.
Yes.
Any questions so far? Hold on, please. Any questions so far? Okay, let's say no question. So, basically, we are trying to assume that somebody has lots of data about people stored in comma-separated formats, and the person wants to apply this data, you know, to our class, create person object of that data. Now, we then said you could go ahead and do this, but this might lead to repetition of code, and all that. We can use this class method. I'll just give it as an example of class method. We can then move, instead of you to split this string and get the individual components and then create a person object, we can move it to become a class method, right? That stands like an alternative to the init method. So someone with this kind of data, okay, I think before it cut where we defined the string, the function called from string, where we pass the string as argument, and then we split it. And after splitting it, we instantiated the class. But now, because it's a method, we return the person element. Okay, so that if you want to make something like, as we have person 1 is equal to, or person 2 is equal to, I can then come here and say, or instead of all of this, I would then be saying person 3 is equal to person dot from string. And I think we need to note that here the first should be the first argument should be the class, right? I think I left that out because now it's like a class method. Okay, so, and you can now call or just say this again, return the person construct a new person object there. Now, instead of us splitting the string, we can just go ahead and pass s in this case. Okay, and then print, just to see that it's being the object was created with person 3 dot first name. Okay, I don't know if it's clear. Is it clear? Any confusion? So this is just another way of us using a method, a popular way which you have this class method used, so to create an alternative way of creating objects of the class based on maybe this kind of instance where we have someone having a special type of arrangement of his data, which is not in line with what we initially expected. So you can create an alternative way of, creating a person object. Okay, so let's keep going. Now, we said we are going to talk about class inheritance. One of the most important advantages, there are about 4 very important advantages of OOP. One of them is inheritance. And this is where we can inherit from other classes. Okay, can inherit from parent classes. So last week we talked about employee. An employee is a person. So I would go bring that code, or maybe I should import it, but let me just go back. So this was our code for last week. We created an employee class. Okay. Sorry. Oh, shit. We created an employee class, and the employee had these attributes. We had these methods. Now, I want to show inheritance using this class. So let me just copy it. Copy this class. To the file today. So I have it here. Let's say after person class, I then go ahead to create my employee class. But now, each employee is a person. So instead of me instantiating an employee, still taking his first name, his last name, that I already have that code here as person. I can, because now employee is inheriting from that person class. But let's do this. Let's comment all these codes first. Let me show something. So let's say I define a new class called employee that inherit from person. So the assumption is for you to be an employee, of course, first of all, you're a person before employee. So if we had a class of person, and then we can also have another class of employee. So how do you inherit from person? You pass it here. Now, if you watch all the other classes, all the time while we've been talking about class, we have not been passing any argument here, okay? But now we are passing an argument of another class. Usually this is supposed to be like this, okay? Without the bracket, it's typically like this because we are not inheriting anything. But now that we're inheriting from person class, if there is a bracket and then we put in person. And you can also inherit from more than one class. But let's just start by inheriting from one class, person. Okay. Now, let me just assume I've not implemented anything and I say pass. So you see that even though I have not written this code, these codes are all comments. These codes, they are all comments because I've commented them out. And I still want to go ahead and I think at this point we can remove all of this. Okay. Just remove all these ones. So many codes. Okay. Fine, we are under inheritance. I want to create an employee. So I can say employee 1 should be equal to employee. Why is it not on? Okay, S. So employees. Now to create an employee, it's going to inherit because it's inheriting from person. I can easily just, it needs to still, or even if I don't have a constructor for it, I think I should be able to just create a person, like an employee like this. Let's try it, save. And then let me see if that works. So I say print employee. Print employee 1. Save it. Run. Okay, yeah. I just want to check something. So because you can see the error message that is thrown, I just instantiated an employee. Remember, I have not written any code for employee. I only just defined the class, but inheriting from person. Then I went ahead and created an object of the class and printed that object, and an error was thrown. What is this error? The person.init missing 4 required positional arguments. These 4 positional arguments are what is required by person. Okay, so automatically, even though I've not written any init function for employees, because it is inheriting from persons, it also has an init method from persons. Okay, and I just tried to do that, and you see that I threw that error because I did not provide these arguments, which are supposed to be provided before you can create a person. Okay, because now this is now inheriting from that class, so it has an init method, even though I have not gone ahead to put any code for it. It's just a pass. But simply because it's inheriting from here, all of these methods that are in person are already in employees. Okay, but now let's go further. The class can still have its own class attributes as we had before. Of course, we'll remove pass. Now, to do our init method for this class, we will not need to start repeating first name and last name because those ones are provided for in the parent class. So what I can do, I can take all the parent class requires, copy them, I bring them here. There's something here that's not in the parent class, which is pay, so I'm careful of that. Okay, now, so I can, let me just put all of this as a comment so that we can follow it step by step. So I'm now writing an init for employees now, noting that employees is inheriting from person's class, okay, taking the properties or the methods in person's class. Employees has access to it. So now I could initialize it using the let me put it this way, person dot init method. Okay, so I say self, and then what do I need from person? Okay, so now if I do this, it's just like I am creating my constructor now from the parent class. I mean, yeah, the higher level class, which is inheriting from, which is person class, right? So there is one additional detail which we have apart from location pay. Then we can add it. Go to pay. Now if I make use of my existing code instead of just typing all over, sorry, Ctrl Z, I could. So I could remove all these ones from comment. And now instead of first, it's called F name, no longer first. And last is called L name today. Okay. So now you see that some of the attributes I needed for an employee are already captured in person. Okay, so I call that super or person init method because I'm inheriting from that class. Okay, I call it and initialize it as a person. Now, because an employee needs more details, an employee needs to have a pay, an employee needs to have an email, I can then add all of this in its method. I hope this is clear. If, for instance, the employee did not need to have additional details, if all these were not needed for an employee, I could, let me just say, like, I could stop at this, just define it using the constructor above here. But because there is need for additional information, that's why you have these extra details. So obviously, an employee will have more attributes than the upper class, which is person. Now, this can also be done using, I think, super dot init. But in this case, I'll just pass in only these ones. This will not be needed. Okay. So that super dot init now, what it is saying is we are initializing is the same thing as what I just removed. You know, there's person. Just know these two are the same. Okay. So I could either write it as person.init or super.init. So this super now is going to pick this init method of the parent class. Okay, so, but I think I'll remove this one. I just put it there for us to see. This should be better. So you're now inheriting that init method from the parent class, and you're adding other attributes to this employee class. Okay. Now, because it's inheriting from persons, so let's see this. Let us make an employee now. What do we need? We need first name, Mikel. We need last name, Obi. What else do we need? Let's say he was born in 1998. And we need his location. He's located in France. See. Now, because he's an employee, I need an extra detail. We are going to pay him 50,000. Okay, so with this now, I can create this employee. Now, even though I've not written any other method for employee, I can call any of these existing methods from the parent. That's why it's called inheritance. I can call any of these methods, like let's calculate his age. Okay, let's calculate his age. Even though we did not write any method in our second class of employees, all we just have is the init method, and we have some other employee details. I could just, you know, say employee one, but what's this? Dot age. So let's see if we can calculate his age. Save it. So we have an error. And what does it say? Type descriptor requires a super object but received a string. I must be making something like a mistake, but let's see if I call it directly person. Save it around. Okay, if I save that person, so I'll have to add self. Yeah. So you can see, I think my super method, there's something that is wrong there, but I'll look at it. Now, I had to revert back to person. Okay. When I used call it directly from the person, you can see that it was instantiated and I was able to have access to this method called age. Okay. So even though I have not written that method in my current class, which is employees, I'm still able to have access to it because I am inheriting everything that the parent class has. Okay, that's where you now begin to see the power of inheritance. Is it clear? Does anyone have any questions so far? Any question? Can you hear me?
Yes, yes.
Yeah,
I hear you.
Okay. Any questions so far?
I'm following up.
Okay. So I think I've just seen why my super wasn't working. Let me try it again. The other way to do it is to use super. But the difference here is whenever you use super, you will not have self. You have to remove self. So, but my super needed to have a parenthesis. F name. Let me save it. And then okay, that's it. So super.init, I prefer to use super than call the name of the other class. Okay, super just means you're using the upper class. Now, what we've been able to establish is that the employees class is inheriting from person. Now, everything that is in person is already available to read. Okay, the class attribute is there. All these methods, if you try them out, you find out that they're working without even having to implement them. But now you can go further and implement other methods, like in our case, employee can have this full name, an employee can have apply raise. I can also decide that, oh, full name should be something that a normal person, human being should have, not just an employee. So I remove it and move it to the parent class so that everybody can have a full name, whether you're an employee or not. Okay. So in this way now you have first, okay, the spelling is different. So I have to just correct it. So you can have a primary class and then a class that inherits from that one. Okay. But of course, you cannot send something like apply raise to the parent class like I moved full name because this is specific to this maybe company. This person is an employee of this company. So you can see every other thing here has to do with the company in LHI. But the company employs people. Okay. So this is where you could even have other methods for a person. Maybe a person can run, a person can talk. You know, all those can be methods or attributes given to a normal person. But for it to be an employee, you have to be a person. So employee now is inheriting from person. We take it further. In a company, you could also have more than one type of employees. You can have a driver, it's also an employee. You can have a manager, it's also an employee. So those classes can be written to inherit from an employee. And once they are inheriting from an employee, there are also all the methods of the parent classes, which is person, is exposed to them. So you can have a person being a driver or a manager in a company. So that manager now, we could say, for instance, the class manager. But this one is inheriting from employees. My manager is also an employee. Then I'll say pass. At this point, you find out that if I try to just create a manager class, there'll be a problem because it's already exposed to this init method, okay, which by extension the other one. So you must fulfill the parent in it, which means you must provide all the necessary details. So in this case now of a manager, I may not need to add extra details. I will just go and say for my constructor, I will copy. In fact, I'll just copy this. Let me copy this and just put it here, right? And go down, super. Sorry. No. This is where we are supposed to be. Super dot init and pass all of this. Okay. And pass all of this to manager. See. So a manager has almost the same, attributes as an employee. But then a manager can now have, as a manager class, he can have his own pay raise. Maybe every employee's pay raise is 5%. We can say manager's own is maybe 7%. Okay. So whenever, remember what you said in the last class, that when it's trying to resolve in the namespace, right? If I put pay raise here, anywhere I refer to as whenever I'm dealing with a manager object, if I refer to pay raise, it will first check within manager to see pay raise. Yeah. If I don't define his own, it will still fall back to use the one of the parent class. Does that make sense? I think it should, from what we learned in the last class. But we can then begin to say managers, their own pay is different from every other normal employee because they are manager. A manager can also have maybe employees, other employees it's managing. You can still improve on this code to add all of that. So this is just like inheritance, showing us that you can inherit from this class. Another example could be you have a parent class animal. You will define some methods that every animal can do. Okay. Now, in a subclass of that animal, you could have dog, or you could have monkeys. Another class, monkey, that will inherit from animal. When they inherit from animal, everything the animal class has, they have it. But then as a dog now, it can have something that only dogs have, which will be other methods you then begin to implement under the dog class. So that's the concept. Instead of you to rewrite all of what the parent class have, you can just inherit from it and use it. Okay? Can keep inheriting like that. So all of this comes very useful when you're maybe designing something, you're thinking of your data, how you want to model it, and their relationships. You can then build them into classes like this and object. I don't know if this is clear. Is it clear? Or is there any area we should look more in?
Okay, this is it a practice that each time we want to write the class inheriting, we always have this init method
Okay,
and
yeah.
this super method.
No, you don't
I
always.
need
You don't always. You can overwrite. There's another thing about classes. You can overwrite. For instance, instead of me to use super and take from the parent class, I can just define another init method. Okay. I forgot to mention that. Thank you for that question. For instance, now, let me just say in my manager class, I think I don't want to talk about his location. Yeah, and the year. All I just want is him to have a first name. I think that's possible. I can just come and write his own self dot first name equal to F name. Then let's say self dot last name, or let's last name equal to L name. Let's just take only these two and then leave that and see how that works. So let's go ahead and make a manager. And run it. Let's see. Okay, because I'm calling age. Let's not call age. Let's call first name. So it's working. You don't have to have all those attributes. But you see the problem, I called age first, right? Before I called first name, I called age. It's exposed to this method. But once I do that, we have a problem. Can you see? Manager has no attribute here of birth, because even though he's a manager, he's still a person, right? And in person, he's supposed to have the attribute year of birth, but he doesn't have it. Okay, he doesn't have it because I changed the constructor.
Software engineering.
Now,
Sorry. Which one?
Does that answer your question? The only reason why I'm doing it is because I know that there are some methods right from the parent class, like its age. You need, for instance, self.age. If you go and subsequently make other classes and change the init to any other one you want, you find out that those other methods now begin to say things like this. There are no attributes. Okay. And you can also override every other method. For instance, now I just overrode the init method. I can override maybe the way I want to write the first name, full name for manager. I want to add manager. Okay, but for a person, I don't want to add it. I can still rewrite full name method in, let me just do it. Copy. In my manager class, I can write the full name. Okay, but now maybe I just wanted to say this. So before the person's first name and last name, I just want to add manager. Now, it will still follow the rule we talked about in resolving namespaces. Whenever you try to run any method, it will first check the class you're in, which is manager. Do we have a method called full name? And yes, we have. So it will just implement that one. If it doesn't find full name, then it goes to the upper classes looking for full name. Does that make sense? So you can override any method, but the key thing you should know is it has access to all those methods that the parent classes had. That's the key thing to note. But you can override it the same way you change the init. You don't have to do super. But we are just doing super before because of the way we structured person. So we knew that for you to use some of the method exposed to person, you must have social data. So we're just carrying it over. But you can just do something different. But other methods, it will still take. So maybe you're just inheriting from employee just because you want to have access to maybe only this method. Okay, you go and override the rest. Like if we wrote maybe animal, like the one I was describing, animal and dog, we could have written maybe a method like movement. For animals, I can say under movement, I can just say animals can hop, jump, fly, you know, different methods of movement. But under dog now, I'll now just write the particular one that belongs to dog instead of general. So those are just like concepts how you can inherit from other classes. So you can have animals and sub-animals. You can have a school, and then everybody in the school has a particular detail that you want to collect in that super class. Then in the subclass, the person that is in a school can be a student or a teacher, which are other subclasses you could make. Okay, because these are just like object models. You're trying to model some type of scenarios. Classes help you to, you know, arrange your code so that you use other codes, and even under object-oriented programming, there are different programming styles, yeah, that you can still learn about how to structure your code. That one is another course on its own. Different structures, like the factory pattern. Okay, they call it programming patterns. Factory pattern is one of them. There are other patterns, but they are all like OOPs, their foundation. Different way of structuring code based on your needs. And what is a pattern? A pattern is just a kind of solution to a problem that over time, as people have been programming and know that, okay, once your problem looks like this, use this pattern. It will be easier for you to manage your data in this kind of problem with this pattern. Then there's another pattern which you can also apply again. But those ones still are like advanced courses in programming generally, programming patterns. But this is also using inheritance is a pattern, okay, which is one of the powers of OOP. So lastly, before our time finishes, there's something I just want to throw in this OOP, magic methods. Magic methods. So these are methods that have double underscore. Then you see the name of the method. Method name. Okay. These ones, they are called magic methods, or you call them Dunder. For example, this init we've been using is a magic method. It's a Dunder method. So these are methods that perform certain actions in our class. For example, now, I can say, how do I add 2 employees? Or let me put it this way, whenever there are different types of magic methods, some of them are something like this. We have underscore underscore add underscore underscore. This is the one that tells you how you add 2 members of a class. And it's this one that is written why when you use the plus sign on string, it will concatenate. You use the plus sign on numbers to add. It's because of this method. Okay. And then one, which is another one, is str.